In this video, we're going to talk about point deforming the renderable mesh with a single-sided mesh, and what happens when you get pieces that are really close to each other, or points on the deformable meshes that are really close to each other, and you get shearing. So there is a new attribute called the piece attribute on the point deform node, and that's what we're going to look at right now as a way to fix this problem. For context, in previous versions of Houdini, this attribute does not exist here. As of 18.5, we now have this attribute that now exists on here, the piece attribute. Now here is an example of what the node graph looked like before this attribute. You would have your simulation or your rest mesh coming in here and your simulation mesh, and you would have to go through and expand and contract groups and paint values on there for an attribute, and then you'd have to remove, using connectivity, remove small islands just to get matching pieces, and then you would deform that. All of that in a for loop. Then you would have to take the results of that, because it doesn't look that good, and then use that to deform yet another copy of your renderable mesh to get back to the proper point value. So let's go ahead and set this up the proper way in our file now. And I'll show you, it's fairly quick and it doesn't require any for loops at all. So let's go ahead and start. First, let's set up what we normally would to illustrate the problem that we're trying to solve here. So I'm going to take one of these other ones that I set up on the top shirt buttons. I'm just going to steal a few nodes by alt dragging them over here. I'm going to disconnect this. And then in this blast node, instead of blowing away everything except for the buttons, I'm just going to blow away everything except for the top shirt. And then we're going to look at the time here, or the time shift here. This will give us our rest state. So I'm just setting up everything as if we would normally do it. So now we would have our piece deformed, but as you can see, our problem right here is there's a lot of these flaps were very close to each other. They were within the radius here of capture when we put it together. So what we can do is reduce the radius, and we can keep trying that until we can get to a really low value. But this is an incredibly low value, and we're still getting some shearing here, so there was clearly some overlap of some pieces here. So the only way to get rid of this is using the new piece attribute. The first step you would want to do here is you're going to have to paint areas. Let's go back to the rest frame here so we can take a look at what it looks like. So you're going to want to paint areas that make sense. You're going to want to paint an area for each sleeve and maybe each panel of the front and back, and of course for each of these flaps, so they indicate separate islands or pieces that we will deform. I'm going to save you the time. I'm going to go ahead and just paste in a value here, paste in a file here where I've actually already done that, and we'll talk about it here. So let's look through. So for each one of these, I went through and declared pieces that I thought were super useful, and I would use these as limiters for painting values. So at the bottom here, you can see I have sort of an island. I called it island top. I ended up changing my mind later. But for each one of these, I could go through and pick one of these islands, like say the lapel or island 1, etc. And I can paint with that value. So one thing I didn't know when I first started Houdini is that you can paint an attribute, and the attribute value does not have to be 0 to 1. The value can be 0 to whatever. It can even be negative values if you want. It's just a number. So I painted up to the value of 8 on this. So if we were to actually take a look at this, you can actually see this. Now if you're not seeing this as you go through and see these values, it's because you need to modify your visualizer. So down here with your paint node selected, you can right click and then scroll down to your list, and you'll see the one that's checkboxed here, and you can edit that value. And what you want to do is edit it from 0 to the number of islands or the number of pieces that you're going to want, right? So I did 0 to 8. So each color is kind of sliced into integers of 8. And if you were to actually look at the geometry spreadsheet of this, I'm just going to randomly grab a few points here, and I'm just going to take a look at these. So if you look in here, I painted the color island throughout each of these, so you can see the values. And I didn't paint them in any particular order. I just grabbed a patch and just painted it that color. So you can see they're whole number float values here. So that's important. They're going to be whole number float values. And if you need to add another piece that's causing spiking, you can add another piece. I did this for the cloak as well. Let me show you that one. As mentioned before in previous videos, I decided not to go with this method because the renderable mesh itself was made of quads and looked quite nice. But you can see here I had up to 22 different values that I painted in this. So you can paint any foreground float value that you choose in your attributes for this cloak. Okay, so let's go back to what we were doing here. Originally I painted this as called island top. I had several separate islands, but I wanted to be able to reuse this node. So I'm just going to go ahead and on the way out of this node here, I'm just renaming island top using an attribute rename to island so that we can use it. So you just make sure that this is the visible node when you get done here. Okay, so what I'm going to do is I'm going to plop this in my chain right here just so I have values. Now, one thing I need to do is I need to transfer my painted values in the rest state from this mesh right here over to my mesh over here, because this doesn't have any island values whatsoever. What we're going to do is we're going to do an attribute transfer. And I'm going to plop that in right here. It only has to be in the middle node, in the rest node. You don't have to add these attributes to both sides, just in this node here. And we're going to get these values from here. Before I do this though, I think I want to convert the island to an integer so that they don't interpolate, because a float value, if you transfer, will interpolate to all kinds of mixed values. So I want to convert that to an integer first. So the first thing I'm going to do is drop a point wrangle here, and that's going to be my output here. And all we're going to do is we're going to call it piece, and it's going to be an integer, piece, and that's going to be from casting the float value of island. So now we have an integer in here. So if you look in the geometry spreadsheet, there will be a piece that is the same as the island, but it's an integer. We want that because it will not interpolate when we do attribute transfer. So when we attribute transfer to the points, we definitely want to drop the piece attribute. That's generally what we're trying to do here. So if we look at this, now we will see there's going to be some piece values on our simmed mesh here, and they're integers as well here. Let's go ahead and take a look and see what that has. So now we have this point deform. Let's go ahead and say both sides have the piece attribute name, so we're just going to go ahead and call that, and let's see what we get for deformation. So go to say like frame 1050, okay, and see what we get here. It's pretty good, but we're still having some shearing here. And the reason is if you were to actually take a look at this triangulated mesh in our attribute transfer, we didn't get good values. There's still some crossover there, so we're going to have to do a trick here to do that. So let's drop a visualizer, and we'll see what the out values are of this. The attribute we want to look at is called piece, and we want to look at it as a ramped attribute. And then I always like the infrared myself, and that's at rest. So let's go back here. So if we go back here, you can actually see some of these colors, due to proximity, are not looking so good. So we can go check out our attribute transfer node and our conditions. We want to make sure you only have one sample. If you have too many, it starts to get really smooth and it starts to look bad. So you want to drop that down. And also our distance threshold, you can go to 0.001 or whatever. But as you get slower, I mean 0.0001, you can start to see the results. It doesn't look so good, right? So distance doesn't work so well here. One of the tricks that we can do here now is a new node called the expand and contract. So I'm just going to go back to the default settings on that just to show you here. One of the things we want to do is make sure that there's no light green on this flap and there's no medium blue on this side. Same thing here, we don't want any orange on this side or any yellow on this side. So I don't know if you can see these colors a little bit here. You can also see the same issue here where we're seeing that shearing in the last example. There's some green points over here that belong over here and some yellow ones that belong over here. Here's a brief description of the process we're going to use to take care of points that are outside our major patch areas. I have here is a grid that represents, say, one of our panels on our top shirt. And here might represent some of the points that are scattered about. These might be on a separate panel and these might be on a separate panel. The first thing we're going to do is use a group expand node, but we're going to use it in the negative. So we're going to step -2, which would actually contract our group. You can see these green points are effectively removed, and we have a single patch here represented by the orange that represent the points that we're going to keep. Next, we're going to expand that group using a number that might be one larger than the contract. We actually have an area that encompasses points that we had previously. So you can see here's the previous one and here's the new one. So this cleans up having any points that might be on separate patches. Let's start by dropping a point wrangle. We'll flip it in here. Let's go ahead and establish a slider that's an integer slider, CHI. We'll call it piece num. We'll go ahead and press this button to build it here. We can see it. We'll set it to this yellow area, which is area 6 right now, so we can see the results. Let's create a temporary group called current piece, and we'll set everything to 0 unless your piece attribute matches the piece num that we're working on, in which case we'll put you in the current group or the current piece group. And here you can see if we actually look at piece, if you actually look at the current piece group, you'll see that most things are 0, but there is membership of 1 here. Okay, so there's a patch in here that is part of this. Okay, next we're going to drop a group expand node. Plop that in. Okay, and we're going to set the base group here to the group we just created, which is current piece. And then if we move the steps negative, you can see it contracts. And if we move it positive, you can see it expands. So we'll set it down here to -2. That sufficiently gets rid of all the extra points here. So that's pretty good for our contract phase. Okay, so let's drop another group expand node here. Now the base group for this one will be group expand 2, which is the output of the previous one. And we'll call this one group expand 3 underscore expand. Call it whatever you want, it's fine. Okay, we'll set it to points here, and what we'll do is we'll expand this, and we want to make sure we encompass the original points plus maybe a row or so maybe 5, I'm not sure. Whatever looks right. Okay, so let's grab another point wrangle, we'll put it here. The first thing we're going to put in here is a duplicate of that integer slider called piece_num. Just copy and paste and generate it. And what we want is the previous piece_num slider to be driven by this one, so let's go and copy that attribute, and then we'll paste relative link here. There we go. So they both will always be on the same value. Then the last step here, and have this only operate on the group expand output of the second group expand. And then all we have to do is set the piece attribute, which is an integer, to piece_num, whatever the value is for this. So that basically rewrites the piece attribute. Okay, let's go ahead and visualize the results here. Let's drag this down and see the output. And yes, you can see that the area is now yellow and it doesn't have any orange bits in it. So let's copy all of these and put them in a subnet. And what we're going to do with this subnet is we're going to add some attributes at the top here. So let's go to the parameters, edit parameter interface. So the first thing we want to do is be able to declare the piece_num, which we did in that very first point wrangle here. So let's just grab that and grab piece_num and drag that up, put that the first attribute there. Okay, we'll just leave it as is. And the next thing we want to do is determine how many steps are in the contract. So we'll drag this one in here, and we'll rename the label here contract steps. Okay, then the other group expand is right below that, group expand 3, and we'll drag steps up here. And we'll put that in there as well, and that should be good to go. Hit accept, and now if we move these, we can see these attributes change. And if we change the piece_num, we can see other areas are affected. That looks great. And our expand and contract values, if we modify those, we can see those as well. Yep, so we can see it's working on each piece. So what we have to do now is duplicate this subnet several times so that we can get one for every piece_num, and that should expand each area and get rid of all our little floating pieces. I just duplicated a bunch of these and changed the piece_num for each one, starting at 1 and moving down the stack. I just sped the video up here so you wouldn't have to watch me do all of this. Okay, so now you can actually see we actually use that piece attribute, and the values are pretty good here. You can actually see we're not shearing any points anymore. So this actually looks pretty good. I did write this as it would be a giant vex node where I wrote some functions that are group expanding and group contracting here. And I looped through the max number of pieces, which is 8, and I created this loop. And this thing works. It's so slow, and I just can't sit around and wait, but it does work. So I've actually turned this off. I will leave this in the final file turned off so at least you can see it. It'll be on the top shared nodes here. The best part about this is that it's very fast and responsive, and you can change slider values to test or increase values on specific patches if you're not getting the results you're looking for. Okay, anyway, so this is the method that we're going to use, and if we actually blend this into our final value here, so this is with everything together. Of course the cloak is not ready because we haven't actually simmed it on top of everything else yet, but we're getting all the pieces there. All the non-simmed pieces we're going to have to add in, like the body and the eyes and the hair and the hat and the bottoms of the boots, etc. So we're going to have a separate chain where we actually go back up to the very top and collect everything that isn't being simmed, pass that down here, and we'll just merge that in here at the end. All right, so I'm going to go ahead and set this same node stack up that we just did here. I'm going to go ahead and do this offline. I'm going to do this for the undershirt as well, and I will give you a quick overview of that in the next video.